There it goes. Alright, so here we go. Here are the 2 questions I want you to consider. Alright, so everybody's thinking hard about these 2 questions. In how many ways can I choose a committee of 3 from a group of 8? In how many ways can I choose a president, vice president, and treasurer from a group of 8? All right, so there's the first 2 questions I want you to think about. Put a couple more up here. How many ways can I award 3? So here are the 2 questions, the different questions you're considering. All right, so let's look at the first 2. Both of them involve a group of 8 people, and both of them involve me picking 3. So they're very similar. Is there anything different about them, or are they exactly the same problem, just worded differently?
They're exactly the same. Different.
Okay, now I'm hearing some saying exactly the same, and I'm hearing some say different. What do you think? Let's have some conversation about it. Vincent?
It's different because I could select 3 people to be a group of 3, but then I could select 3 people and switch them around between president and vice president.
Ah. Think about that for a second. Vincent says, okay, let's just pick 3 people. Let's just take the front row here. Okay? If I take the front row right here, and they're my committee, does it matter whether I pick Dan first, and then Nick, and then Marcus? Does that matter if they're just my committee? No. But if I assign them roles, president, vice president, and treasurer, then it matters, because I can have the same 3 people, but president, vice president, treasurer is different than president, vice president, treasurer. Do you see what I'm saying? Fundamentally, the order of choice, I'm picking 3 people out of this group of 8. The order of choice does not matter in the top question, but the order of choice does matter in the bottom question. Does everybody see that? All right, let's look at the next 2 questions. Now we got 10 people, and I'm giving 4 prizes. In one case, the only difference here is, in one case, the prizes are identical. So I'm going to pick my favorite 4 people. I'm going to give all of you a Ticonderoga pencil. Best pencil ever made. Here, I'm going to pick my favorite 4 people, but somebody's going to get a first place ribbon, a second place ribbon, a third place ribbon, a fourth place ribbon. See the difference? Are these the same problem? No, for the same reason this one wasn't, right? In question number 1, does the order of choice matter? If you're going to get the same prize as everybody else, then you just want to get picked, right? You don't care where you get picked, first, second, third, or fourth, you just want to get picked. But if I'm giving away special prizes, then don't you want to get picked first? So the difference here always comes down to one thing: order of choice. Does order matter? If order matters, we have what we call a permutation. Is that word familiar to you?
Mm-hmm.
Permutations mean order matters. This is a permutation problem. This, we would say, is the number of permutations of how many people do I have? 8, taken 3 at a time, which is also written like this. You have to get comfortable with both notations. This means the number of ways I can pick 3 things out of a pile of 8 in order matters. The permutations of 8 things taken 3 at a time. Which of these is the permutation problem? So this would be the permutations of 10 things taken 4 at a time, which is also written like this. We just have to get comfortable with both notations. Now, if order doesn't matter, then we have what's called a combination. So this is the combinations of 8 things taken 3 at a time. And this is the combinations of 10 things taken 4 at a time. So P stands for permutation, C stands for combination, and you know you use P if order matters. Both of these problems involve choosing. If order matters, it's a permutation. Okay? Now let's get our calculators out. If you press your math button, is your regular math button there, right there in the first column, you'll notice you have a string of options across the top. Click across to PRB, that's your probability. And you'll notice that the second and third options are NCR and then PR. So if we wanted to type this in on our calculator, for example, if I wanted to know what that equals, I would type 8. First I gotta put it. Go back to your home screen, type 8, you gotta put that number in first. Then go into your math menu, click across to probability and down to NCR, because we're doing C, and then press 3. Did it say 56? All right, now let's do this one. Let's do this P one right here. Let's find 10P4. What's 10P4? We do it the same way. 10, math, all the way over to probability. Now we want P this time, so make sure you're picking P. And then 4. I got 50/40. Do you? Okay? So that's how you use those buttons on your calculator. That's where they are. So you can actually type them in and get some answers to the questions. Everybody okay with that? All right, let's back up and talk about a couple of other things. There's all kinds of different problems we're going to be doing. Let me throw a couple in here and see. Let's talk about this one. We're going to be doing a lot of probability. How many 5-card hands contain exactly 3 lines? Okay. Now, we need to talk about this for a second. How many 5-card hands contain exactly 3 diamonds? Okay, so what would that hand look like? It would have 3 diamonds and what? 2 something that's not diamonds. So we're going to have 3 diamonds and 2 non-diamonds. Everybody in agreement? All right, how many diamonds? Okay, so here's my deck of cards. I'm going to split it into 2 piles. Here's the diamond pile. Here's the not diamond pile. How many cards are in the diamond pile? 13. How many of those am I picking? 3. Okay, is this a 13P3 or a 13C3? Does it matter what order I pick them in, guys? No, I'm not playing some weird game. I'm sure there are cases where it does matter, but I'm just trying to build a hand of cards, okay? So the order I choose them doesn't matter. So this part of the problem is going to be 13C3. Would you agree with that? There are 13 diamonds. I am picking 3 of them.
Where did you get 13?
Uh-oh.
52. 52, okay.
52 cards in the deck, 4 suits, 13 of each, right? Now, I gotta pick 2 more cards. Remember, this is a 5-card hand. You've only picked 3 cards so far. So now I'm over here to my non-diamond pile. How many cards are in my non-diamond pile? 39. All the spades, hearts, and clubs. And how many of those do I want? So what's that gonna look like? 39C2. Now we got to talk about what we're going to do with each number. Would you agree you can type that in on your calculator and get a number, and you can type this in and get a number? Okay. We got to figure out now what do we do with those 2 numbers. So I'm going to step over to the side and I'm going to ask you this question. I have 6 jumpers and I have 9 shirts. Assuming that I don't care whether things match or not, which you know is absolutely true. How many outfits do I have? 54. How'd you do that? Every shirt can be matched with every jumper. Multiplication, it's called the fundamental counting principle. We just multiply them. So if I can pick a jumper 6 ways, and I can pick a shirt 9 ways, then I can do them together 54 ways. If I can pick a diamond this many ways, and I can pick a non-diamond this many ways, what do I do with these 2 numbers to find out how many ways I can do them together? You multiply them. Whenever you are doing things at the same time, you multiply them. So if you were going to pick a color and a number, you would multiply it. The options. If you are doing this and this at the same time, diamonds and not diamonds, you're going to multiply them. That is different than this question. I go down to the ice cream parlor. We'll keep it simple. There are 3 flavors of ice cream. That's all there are. I can get 1 scoop or 2 scoops. How many different ice cream cone options are possible for me? Well, let's see. only get one scoop. Let's look at this first. How many different cones are possible if I only get one scoop? Just 3, right? Okay, so there's 3 of those. What if I get 2 scoops? All right, now think about this for a minute. I'm going to get 2 scoops of ice cream. How many choices do I have for my first scoop? I'm standing there at the counter and I said, oh, I want that one. How many choices do I have? 3. Now I want a second scoop. How many choices do I have? 3. I can have 2 of the same, right? And in my case, I would. They would both be chocolate. Now, scoop 1 and scoop 2. Same cone. What am I going to do with those 2 numbers? Multiply. So there are 9 2-scoop cones possible. So there are 3 single scoops, or I could get 9 double scoops. How many total cones are possible? 12. Do you see the difference? This is not an and. I am not doing both of these at the same time. I am getting 1 scoop, or I am getting 2 scoops. When you have that situation, it's an add. It's an add. If 2 things are happening at the same time, it's a multiply. But if you are doing 2 things, either or, it's an add. All right. So let's go back to our cards. Let me change one word. What is at least 3 diamonds in? You have a 5-card hand. What does at least 3 diamonds mean? I could have 3, or 4, or 5. So I really have 3 separate problems. I got 3 diamonds, or 4 diamonds, or 5 diamonds. Now this one we already did. Remember, what did we say this was? This was 13C3 times 39C2, and everybody understands where those numbers came from? All right, now what does 4 diamonds look like? 13C4 times. Everybody okay with that? And then? Yeah, now if you want to go ahead and put 39C0 just to kind of have everything looking the same, you can. But obviously if you're picking 0, you don't need to include that. So I know now how to type this in on my calculator. I could type this in on my calculator and get a number. And I could type this in on my calculator and get a number. And I could type that in and get a number. What am I going to do with these 3 different numbers that I end up with? Add them. Because it's either or. They are not happening at the same time. You are not getting 3 diamonds and 4 diamonds and 5 diamonds. That doesn't make any sense. You're either getting 3, or you're getting 4, or you're getting 5. Why is this a multiplication? Because you are getting 3 diamonds and 2 not, right? At the same time, same hand. So that's a multiplication. All right. Okay. All right, let's take what's a good 3-letter word? I need a 3-letter word.
Cat.
What?
Cat.
Cat? That's a good word, yeah, cat. All right. So here are 3 letters. Question is, in how many ways can I arrange these letters? reason I only wanted 3 is I can actually write out the options. So I'll go ahead and do that. I think that's it. Does that make sense to you? Now, obviously, if I had a bigger word, I would not want to be doing this. It's going to take me forever. I mean, if I had 5 letters, this would take me forever. So I want to think about the math that's going on here. So here are my 3 letters. Actually, here are my 3 letters. And these are the blanks I'm going to put them in when I grab one and stick it up here. So here are my 3 letters, C-A-T. I'm going to shut my eyes, reach in and grab one, and put it right here. How many options do I have down here? 3. So I have 3 options. That does not mean I'm putting 3 letters in that blank. It means I have 3 options for that blank. All right, so I grabbed one and stuck it on there. Now I got to grab another one. How many options do I have now?
2.
And what am I going to do with these numbers? Because I am picking a letter and a letter and a letter to make this word. What am I going to do with these? Multiply them. That pans out, right? There's 6 options. So if I had a 4-letter word, then what would that look like?
4, 3, 2,
4, 3, 2, 1. Anybody know what we call it when we go 4, 3, 2, 1 or 3, 2, 1 or 5, 4, 3, 2, 1? Anybody? There's a word for that. Anybody know what it is? This is called 4 factorial. And if you go back to your math menu, the factorial button is one of those right under the NCR or NPR. So if you want to know what 4 factorial is, you can just press 4 and then your factorial button and up it will come. Or you can type 4 times 3 times 3 times 1 if that's what you want to do. Alright, so if I had a 5-letter word, how many ways could I arrange 5 letters? 5 factorial. 6 letters would be 6 factorial, and so on and so on and so on. Now I'm going to throw a wrench in there. What happens if we have a word like this? Yeah. It's going to be a little bit different. Let's take a look at it for a second. And I went ahead and used a different color. So that you can see the 2 E's being different from each other. But the reality is, kids, if I didn't use a different color, what about these 2 words? And these 2? And these 2. So in other words, there really aren't, there's still 3 letters here, but there really aren't 3 factorial ways to do it. There are really only just 3. This is a situation where we have what we call duplicates or repeats. When you have duplicates of anything, and it can happen with, it can happen with identical textbooks, it can happen with identical coins, it can happen with identical beads in a necklace. Anytime you have duplicates, identical objects, you divide by the duplicate's factorial. Okay, here's what I mean. We have 3 letters, right? We just got done talking about if you are arranging 3 things, it would be 3 factorial. That's the starting point. But because two of those are the same, we have to divide by 2 factorial. We divide by duplicates factorial. We divide by duplicates factorial. So if I had 3 identical pennies that I was arranging, I would divide by 3 factorial. However many identicals you've got, you divide by that factorial. So let's take a look at another word. How about the word committee? Did I spell that right, I hope?
3 factorial.
What?
Divide by 3.
Well, what do we start with? Start with how many letters do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We start with 9 factorial. Always start with the number of things you're arranging. You are arranging 9 letters. I know some of them match. I'll deal with that later. Right now, I'm starting with 9 letters, 9 factorial. Some of them are the same though. I have 2 M's. 2 factorial, that's the M's. I have 2 T's. 2 factorial. That's the T's. I have 2 E's. Another 2 factorial. That's it. When you type this into your calculator, either use parentheses around the entire denominator, or get 9 factorial divided by 2 factorial, divided by 2 factorial, divided by 2 factorial. You have to divide by all of these. I think parentheses is probably the easiest way to go, but do it however you want. Make sure you're dividing by everything. All right, let's try the classic example, and then we'll move on to one more topic. Can't do this without talking about Mississippi. All right, so here we go. How many ways can we arrange the letters of the word Mississippi? Well, what do we start with? How many are there? 11. So I start with 11 factorial. Now, what am I going to divide by? I've got 4 S's. So 4 factorial takes care of the S's. I've got 4 I's, so I'll divide by another 4 factorial on the I's. And 2 P's. Let's type that in. Make sure we can all get the right answer. So 11. The factorial button is in your math prob, right under your NCR. I got 34,650. Anybody match that? You okay, kids? I've got one more thing to throw at you. One more thing. So let's stop and recap here. What are some of the things we've talked about today? What are some things we need to remember? Permutation, combination, what's the difference? Permutation, order matters. Combination, it doesn't. All right, we talked about the difference in a problem between an and an or. An and tells me I'm going to be multiplying, and or means I'm going to be adding. We've talked about how to deal with duplicate of anything. I've only done letters here, but it could be duplicates of anything. If you have 2 yellow beads, you're going to divide by 2 factorial. If you have 8 pennies, you're going to divide by 8 factorial. Alright, and here's our last thing to talk about today. Let's suppose you go down to the cafeteria and you get yourself a rectangular tray and you choose a pear, a banana, and an apple. How many ways could you arrange that pear, that banana, and that apple on that rectangular tray like that? How many ways could you arrange those 3 letters? What? 6. 3 factorial. That's like a word. It's not a real word, but aren't you just arranging those letters? Right? I'm going to write them out one more time. There's a point to this. You will see. Okay, there they are. There are the 3 ways, or 6 ways. But let's suppose that instead of a rectangular tray, you got a circular plate. Let me look at these 6 arrangements in a circle. So here are, on the rectangular tray, here are the 6 arrangements. And I just took those and put them on a circular plate. Would you take a look at those circles for a minute? Tell me if you observe anything. I'm not going to look at those 3 plates. This one right here, this one right here, and this one right here. Do you notice anything about them? Riley?
I don't know if it's right, but like when you turn them, they're the same.
Really? Has there been any rearrangement there? What happened going from here to here? I don't think I physically rearranged anything. Everything is, relatively speaking, exactly in the same position. What did I do? Just as Riley said, what did I do? Rotate the plate. And isn't this just yet another rotation? When you arrange things in a circle, there isn't a beginning and an end. Does that make sense to you? So there aren't as many ways to rearrange because you're not physically picking up and moving things to get all of these 6 different arrangements. Now, are these 2 different from each other? Yes, because if you're P, A is over here and B is over here, but here if you're P, A is over here and B is over here. So there's a difference between these 2. But there is no difference between these 2. When you arrange things in a circle, kids, it's 1 less factorial ways of doing it. So if I had 10 kids on a log, it would be 10 factorial. But if I had 10 kids around a campfire, it would be 9 factorial. 1 less factorial when you arrange in a circle. Okay? So if I have 6 kids, and I'm lining you up in a straight line right here, 6 kids in a straight line would be 6 factorial. But if I put those 6 kids in a circle, it would be 5 factorial. Always one less factorial when you arrange in a circle. Okay? Some big concepts. We only really have one more big concept to talk about tomorrow. But let's review real quick. Combinations, permutations. You read the problem and you say to yourself, does order matter? If it does, it's a P. If it doesn't, it's a C. If anything repeats, if you have duplicates of anything in the problem, identical objects in the problem, you divide by the identicals factorial. If you're arranging in a straight line, n things in a straight line is n factorial. If you're arranging in a circle, it's n minus 1 factorial. And what does factorial mean? We use that word a lot. What's factorial mean? 8 factorial means you start with 8 and multiply 8, 7, 6, 5, 4, 3, 2, 1 all the way down the line, right? And your calculator will do that for you. All right, I'll put your assignment on the board so you can practice a little bit.